everyone. Thank you for joining us for today's webinar, Visual Regression Testing at the Speed of Unit Testing, with Senior Architect and Evangelist Gil Tayal. So if I'll talk about all the amazing things that Gil has accomplished in his career, it would take us more than the hour we have allocated for this session. So I'll just give you the highlights. Gil is a Senior Architect and Evangelist at Applitools. He has over 30 years of experience with software development. He has co-founded Web College and worked on some of the largest projects at Wix. Gil is also a sought-after public speaker, and he frequently talks at notable international conferences about test automation and software development, such as Selenium Conf India, Star West, Star Canada, and more. You can catch him live next month at Agile Testing Days conference in Germany. So I suggest we let Gil do the talking now. So Gil, the stage is yours.
Thank you, Adi. Visual regression testing at the speed of unit testing. And I have to admit, I'm especially excited about this webinar because it is showcasing the culmination, if you want, of a year's worth of effort of my team and myself. We are finally launching the Cypress SDK and the visual grid, and it's really, really exciting to be able to show the work that we've done for the past year. I think it's big, and hopefully I'll show some of why I think it is exciting in this webinar. Okay, so I think we're good with about me. Adi filled that up. First of all, in this webinar, I want to talk about testing in general, developer testing in general. I want to talk about visual testing. I want to talk about why visual testing at speed is crucial. And finally, I will obviously explore the Applitools SDK for Cypress and Storybook. We'll demo them and see them in live action. So, first of all, let's talk about the main schools of testing. From my perspective, there are two main schools of testing, and arguably. The first I call the pyramid school. The pyramid school is where you have lots of unit tests, little integration tests, and very little end-to-end tests. The emphasis here is on unit testing, and we'll see in a second why. The second school I call the diamond school, where there's little unit tests. There are unit tests, but not a lot as the pyramid school. Lots and lots of integration tests and very little end-to-end tests. A variant of the diamond school, Kent C. Dodds was a major public figure in the realm of JavaScript and front-end testing, calls the pattern the trophy of testing. As you can see, very little unit, lots of integration, very little end-to-end test, but Kent Dodds also adds static analysis using lint and others. So we're both in the same boat in that term. But let's compare the two. The pyramid of testing emphasizes unit testing. And to understand why, we need to understand what happens when we go up the pyramid or up the diamond. The higher we go, the more confidence we have in a test. An end-to-end test, if it runs, it tests the whole system. So I have if it runs and passes, I have a very big confidence in that system working. Unit tests, on the other hand, each one tests a little module or a little class. So yeah, I know all of them work, but do they work together? Little confidence there. Unfortunately, we can't all do end-to-end tests because the higher we go, yes, the more confidence we have, but the slower things become. Not only do they become slower, they become flakier, and in that sometimes tests don't pass just because. So the pyramid of testing and the pyramid school emphasizes unit testing. And when when I do unit testing, I actually have to mock things up because if I test one unit and it depends on another unit, I can't test them together. So I do lots and lots of mocking. It emphasizes those lots of unit tests because it wants speed of testing. It sacrifices confidence for speed. The diamond of testing still believes in unit testing, but most of it is integration testing. It sacrifices some level of speed for more confidence. It tries and it's to make those integration tests not as fast as unit, but fast enough, but it definitely sacrifices speed for confidence. Which is better? What do you prefer? Lots of unit tests, lots of mocking, less confidence, or you're into more integration tests, more confidence, but less speed? Well, you know what? Yeah, I have my own preferences, but they don't really matter because it's a religion. I've seen people talk about these things and argue, and it sounds like arguing about religion. Both are great. Do whatever you feel is right for you. I'm not. I'm definitely not judging. Um, but there are commonalities, and I want to really talk about the commonalities. In both schools, the pyramid school and the diamond school, there are three commonalities. One, the need for speed. Both of them emphasize speed. Unit testing, the pyramid school, lots of speed. The diamond school, less speed, but still there is an emphasis there. Both of them have very, very few end-to-end tests because they're really, really slow and very flaky. And both talk about functionality only, and we'll get to that because that concerns us and visual testing. So let's talk about the three of them. The need for speed. Let's first talk about the need for speed. Why do we need speed? And the answer is really, really simple. We want agility. And I actually am not a big fan of that word, agility. It's been co-opted to mean lots and lots of processes like Scrum and Kanban, and there's all these bureaucracies with velocities and points and story points and everything. For me, I want to go back to the origins of agility, which is the Agile Manifesto. You have a URL there, which you can look at later. It had 4 rules. It had 4 emphases: individuals' interactions over process and tools. For me, the most important thing is working software over comprehensive documentation. And the last one, also responding to change. That's the agile part, where you really, really want to be agile on your feet and not follow like a 6-month plan, which in the end isn't what the customer really wanted. But the most important thing for me is working software. The software always has to be working. Even when you're in development, the code in your master, in your trunk, Git, in the Git master, always has to be working. In essence, a lot of companies that do agile, if they do it really, really correctly, then there's no release. The code is working in master, you can release whenever you want. And that for me is the essence of agility. The code is always working. I'm just adding features as they come along, and there is no release. I can release whenever I want. Let's take a step back for a second to talk about the next issue. And the next issue is, how do we get to a place where I can release whenever I want? And the answer is pretty simple, and it concerns QA and testing. In essence, the testing people understand it as the shift left mechanism. It says throwing things over the wall must die, where a development team works for like a month or 2 weeks or whatever, finishes, does a little bit of manual testing just to make sure that everything is okay, and then throws the release over the wall to QA, which does the testing, throws back over the wall bugs, and the cycle goes on. This must die if we want working software always, because that means that whatever is in master has to be something that can be released. In essence, it's the QA gateway. The QA gateway, which says QA must approve a release. If I do not want releases happening again and again, if I want releases to be happening again and again and again, we need to stop that thinking of QAing all the time, or at least do QA all the time, but never have it be a barrier. What this means is that developers must write the tests, not only QA, but developers. And tests must be part of the development cycle and not only of the development QA release cycle. This means the test must be fast, and it must be fast. And this is where the need for speed comes from the fact that we live in an agile world. There is no release. Working software over processes and documentation. Developers' tests must be really fast. We can't wait for that nightly to happen, take half an hour or an hour, and then get back the results. Developers want to commit and push, and they want to do it now. They want to run the tests, but they want to know that the code runs, that the tests run, but they want to have that answer as soon as possible. How soon? My rule of thumb, have the test run in between 2 and 5 minutes. If you can even less, fine. If it's a bit more, fine. But those half hours, at least for the developer testing, that's a problem. So rule of thumb, 2 to 5 minutes. Let's go for the next commonality between the diamond school and the pyramid school. Very little end-to-end tests. That's important. And first of all, let's talk about what they are, because they concern us, especially in this webinar. First of all, they're different from front-end and back-end. An end-to-end test on front-end tests the UI. An end-to-end test on the back-end tests the API of the back-end. In essence, and we'll be talking more about front-end testing in this webinar, because visual testing concerns front-end. So it's essentially running a browser and testing the app UI through a browser using browser automation. With or without the backend, there's a whole school of thoughts there. Do we test with the backend, without the backend? But I'll leave that for another webinar. And unfortunately, well, they are perceived as slow because if we test it, especially if we test it with the backend, those tests are slow. And they are. And if it's just the front end, as I said, they're much faster. But the beautiful thing is that there's a new breed of browser automation tools that makes those tests run faster. The big representatives are Cypress and Puppeteer. And if you write tests in Cypress and Puppeteer, especially if you don't involve the back-end code, but test just the front-end code, you can fit those end-to-end tests in the 2 to 5 minute limit. And the third commonality, they're functional only. They test the functionality of the application. And again, which brings us to the second talk, the second discussion about visual testing. I want to take again a step back. We're always going to step back, don't worry, but we'll get forward a little. Why do we even write tests? Why do we write code that tests our application? And my answer, it's a very special answer. It's to remove fear. And what fear? First of all, we have fear of adding code. I add some code and I have a fear that it's breaking something, as you can see in the animated GIF there. There's the fear of removing code. Essentially, I'm really hesitant removing code because, well, you can see what happens sometimes because everything is interconnected between themselves. So sometimes what we want to do is we want to refactor the code, but there's a fear of refactoring. If I do refactoring and I don't have tests, how can I know that I haven't broken anything? So there's the fear of refactoring. And functional testing solves that. I add, remove, refactor, I run the tests, whether they're unit, integration, or end-to-end, and voila, if the tests pass, all my refactoring, all my adding code, no fear. I am now fearless. Testing removes that fear. And I always recite the litany of fear from Dune, from the really great book by Frank Herbert. I must not fear. Fear is the mind killer. Fear is the little death that brings total obliteration. I will test my code. I will permit it to pass over and through me. And when it has gone past, I will turn the inner eye to see its path. Where the fear has gone, there will be nothing. Only my tests will remain. I do that as an inspirational thing because I think it's really important for people to understand that testing removes fear. Testing enables us to write code without having that fear. Once you recognize that fear, you start to test. There's one teeny tiny area of my code, which, and I say teeny tiny, I'll do air quotes because it's a huge part. Some tiny area of my code that functional tests do not test. And what part is that? And well, it's the HTML and the CSS markup and the images and the SVGs, etc., etc. When I change my HTML and CSS, when I refactor it, when I add or remove code from that, do the pages still look like they should? That's a big question. Yeah, the checkbox is disabled. I can check that using functional tests, but does it look disabled? When I do a to-do, when I complete a to-do in a to-do MVC application, does it look striked out? Does the whole page look okay? Etc., etc., etc. Functional tests don't help me there. So anytime I add markup, CSS or HTML, remove markup or refactor markup, I live in fear. And visual testing enables me to live without fear whenever I do these kinds of things. That is, for me, critical to do visual testing, to enable me to have no fear when testing HTML, when writing HTML and CSS. So yeah, I must not fear, and I will visually test my code and not only functionally test my code. Unfortunately, something is rotten in the state of visual testing. And I will talk about that. There are a lot of things problematic. I will talk about one thing, especially things that concerns us in this webinar. There's the whole issue, which some of you may have heard of, the false positives, false negatives. That is absolutely true. You need really, really good algorithms to check to visually test your application, and we'll talk about that. But that is not what I want to talk about in this webinar. What I want to talk about is the problem, and we'll talk about the solution. But first of all, how does one go about testing an app, visually testing an app? And the answer is similar to all visual tests. First of all, we automate the browser, just like a functional end-to-end test. Do as a user would. Use Selenium WebDriver, use WebDriver IO, Cypress, whatever, Puppeteer, lots of automation tools. For each page we would like to visually test, we click using the automation, okay, to get to that page, take a screenshot of that page, compare it to a baseline screenshot, which you took and approved the first time the test ran, so you already have a baseline. Is it the same? It's exactly the same? Yay, you are visually perfect, you can go on to the next test. Is there a difference? It's probably a bug. Sometimes it's not, sometimes it's a good difference. So like added a button or whatever because it's a new feature, fine. Update the baseline image and continue on to the next test. And obviously the comparison brings with it a lot of false negatives and false positives. But if you had good algorithms, and Applitools really, really helps you in that area, then you won't have any false or negative results. False positives or negative, false negatives, sorry. And this is how test code looks like. Just a sec. First of all, you navigate, as we said. Then you click, navigate to a page, to the application. Click to get to a page. Check the screenshot. Do it. You take the screenshot, compare it to the baseline. Then click. Check the screenshot. Click, check the screenshot, and so on until you've visually tested your whole application in the various states. Simple, right? Yeah, right. I wish. And I'm not going to talk about false positives and false negatives. Why is it not simple? The answer is because you need to visually test for different browsers. Chrome, Firefox, Safari. Not only that, you need to test for different responsive widths and pixel densities. So a regular desktop is 1000 by 700, 1024, but the pixel density is 1. An iPhone is like 3000 and whatever, but the pixel density is 2. Tablets are different widths, Retina displays are different width, and they all affect your HTML and CSS and how it looks. How does it look in an iPhone? How does it look in a regular desktop? How does it look in a wide desktop? And today with responsive design, this is not just, whatever. The pages look very, very different, and you need to visually test them. So that test we wrote, navigate, click, check screenshot, I have to do it in Chrome in 1024, in Chrome in 2500, in Firefox in 1024, on an iPhone, on an iPad, etc. This is problematic. Do I run each test, let's say 10 times for all the different variations I want to test? Well, no, that's crazy. Remember the need for speed? No, we don't do it. Not even if you have a really good tool like Cypress. It still takes too long. And why is this not a problem in functional end-to-end tests? Well, for some companies it is. You need to test across a wide variety of browsers. But browsers have slowly over the years converged functionally. So a lot of browser testing, you still need to test for variations, but a lot of things have converged, so you need to do less testing in them. So a problem is we need speed. A new breed of tools make E2E tests very fast. Unfortunately, good visual testing takes time. How do we solve this problem? Answer, as usually, divide and conquer, as usual in computer science. We parallelize. Let's talk about one solution. How do we parallelize? The answer is, well, first of all, we can parallelize the test. Run the test for Firefox, Chrome, and Chrome bigger resolution. Test them in parallel. Run the tests again and again, but in parallel instead of serially. That works, but it's difficult to set up. You need like a grid of computers running the various browsers, and it's a problem because you need to run those tests again and again and again. There is a better solution. There is definitely a better solution for that. And the answer is pretty strange, but I love it, and this is what I've been working. My team and I have been working for the past years. Why don't we parallelize just the taking of the screenshots? And I'll slowly explain how this goes. Let's take the test. So click, check screenshot, click, check screenshot. What if we could somehow take that screenshot, but not the screenshot, take that page, we want to test it in various browsers, various widths, and throw it at a lot of browsers in some kind of grid, but not throw the test, just the page. I throw the page, and then in parallel, I throw it at lots of browsers, and then in parallel, I can take those screenshots. As you can see, those browsers will generate the screenshots for me in parallel. So not only can I do the different widths in parallel, I can do the different screenshots in parallel. So those 3 screenshots multiplied by the number of widths and responsive widths and different browsers, I can do all of them in parallel. So whether I have 1 screenshot, 5 screenshots, 10 screenshots, lots of widths, less widths, it all takes roughly the same amount of time, a little bit more probably, but roughly the same amount of time as if I had 1 screenshot for 1 width. The more I can parallelize, the more we can get done. But what does it mean throwing the page, sending the page over to a browser? How can we send a page over to the browser? And the answer, something we call it at Applitools DOM snapshots. DOM is the document object model. It's how the page looks like at a specific time in the browser. So when I do click, the page looks a certain way. The reason it looks a certain way is that all the HTML elements are in a certain configuration. I can take all those little HTML elements, what is called the DOM, the document object model, and serialize them, for example, to JSON. I can take all that DOM and I can wrap it with all the images and all the CSS and all the SVG. If I bundle it together, I can recreate that page whenever I want. I don't need to have a browser anymore. I can recreate the page whenever I want using that DOM snapshot, using the DOM elements and using the images, SVGs, CSSs, etc. So I bundle that and throw that at the various browsers. I take the DOM snapshot and throw it to the various browsers in parallel, and those various browsers can now take a screenshot. We give them the DOM snapshot, they show the page as it would have looked like, as it should look like, and then screenshot, 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 in parallel, get the screenshots in parallel. This is the power of parallelization and the power of DOM snapshots. What do we do with those DOM snapshots? Well, as I said, we throw them, we create screenshots, and then because we're Applitools, we send them over to the Applitools iServer. The Applitools iServer knows how to compare those screenshots with the baseline screenshots we took before in the first test. And that's where the false positive, false negatives go away, because there are really, really sophisticated algorithms in the Applitools iServer that knows how to deal with all those problems. It's basically looking at the pages not as a computer would, pixel by pixel, but rather as a human would, ignoring the little anti-aliasing differences and one pixel little things. It knows how to compare those in the correct way. And then it can give the results. This screenshot is fine, this screenshot has a difference, and this screenshot is also fine. But the way we take those screenshots is not in the client, not in the computer running the tests, but rather the computer running the tests is sending the DOM snapshot, and we are taking that DOM snapshot and in parallel running it on different browsers, not the test, only the DOM snapshot, running it in different browsers in different display widths and taking screenshots. Which brings me to the visual grid, because at Applitools we have implemented just such a system, and we call it the visual grid. A visual grid takes a DOM snapshot from wherever, sends it to lots and lots of browsers. We have hundreds and even thousands of browsers, Chrome and Firefox currently. In the future, we will also have IE and Edge and maybe Safari. It throws them at these browsers in parallel, generates the screenshots, send them to the Applitools iServer in parallel, get back the results, and return those results. Now, the big question is what? I need to write tests to create DOM snapshots? And the answer is, well, the answer is who uploads the DOM snapshots? Who, when I want to check a screenshot, takes the page, creates a DOM snapshot, and uploads it to the visual grid? And the answer is we have SDKs that do that. Currently, we have two SDKs, the Cypress SDK and the Storybook SDK, which we'll be demoing. In the future, we will have more SDKs that know how to use the visual grid. So these SDKs, the Cypress and the Storybook, don't take snapshots in the test, in your computer that is running the test. Rather, it's taking the DOM snapshot, bundling it, sending it over to the visual grid, and that is where we can take screenshots in various widths and in various browsers in parallel. So Applitools Visual Grid, as I said, integrates with Cypress, Storybook. In the future, we'll have Selenium WebDriver, and who knows what else. Okay. That's great for talking. How do I write tests? Let's look at the code. So here we go. Visual testing using the Cypress and Storybook SDK and the visual grid. So you don't need to go there. Don't worry. I will show everything using Visual Studio Code. But in essence, this is the GitHub URL. You will have it at the end of the webinar. It will be in the last screen. You will be able to copy it. And I believe Adi will be sending over the link in the end. So don't worry. Just wanted to know. And there we go. This is Visual Studio Code, and this is basically the Git repo which I cloned. And let's start with Cypress. First of all, before we start with Cypress, what application are we testing? Let's see. I will do an npm start. Npm start. Npm start will start my application, and I need to go to localhost 3000. And there we go. This is the application. It's the classic to-do MVC, clean dishes, write webinar, do webinar. So, and we're done with write webinar. And in the end, we'll check the do webinar, hopefully. So that is the application under test. That's great. Now, we want to test that application under Cypress. Cypress SDK. So let's look at a Cypress test, and don't worry if you don't know Cypress, we're good. I will show and I will explain. I will even make it a bit bigger. So this Cypress test is a Mocha test. All Cypress tests are Mocha tests. You have a describe, which groups a set of it methods. Each it method is a test. We have before and after, which enables us to do things in the beginning, before all the tests, and after at the end of all the tests. And then the tests, let's look at the tests. For example, to create a to-do, I get this element, the new to-do element. I type into it to-do item 1, which is buy some cheese, and I type enter. After that, well, let's ignore the check window. After that, I click another, again at new to-do. This will create another to-do item, and that's showing a couple of to-dos correctly. The last test will just create a to-do and toggle all of the there's a toggle all, which toggles all of them, as marks them as completed, and we're done. This is the test, but we want to visually test. So what we do is we call sci.eyesOpen. I've already installed Eyes Cypress. I've already installed, and I will show how to do that later. But first, I want to run the test. I've already set it up. So the only thing I need to do is sci.eyesOpen, give it a batch name. That's not necessary. You can choose the defaults. And in the after sci.eyesClose, this will close the test. Whenever I want to check the window, check the screenshot, I call sci.eyesCheckWindow. Eyes open, eyes close, and eyes check window are not part of Cypress. They are part of our SDK, the Applitools Eyes Cypress SDK, which you npm install into your project along with Cypress. Just run a setup, and the plugin, the Eyes Cypress plugin, will be installed into Cypress and will integrate as transparently as you can see. So I do eyes check window wherever I want to check the screenshot. So I have 1, 2, 3, 4, and 5 check windows running in my app. So here comes crunch time. Let's run it. npm run eyes Cypress. What this will do, it doesn't run the test. It opens up Cypress. By the way, you need to set your Applitools API key as an environment variable, or you can pass it through code if you wish to do so. I've already done it, so I don't need to do it. But remember to do that before. By the way, if you want to try things out, this GitHub repo has a full README with full instructions. You can try it out at home. Applitools has I think a 14-day trial, definitely a trial, free trial, so you can try it out at your heart's content. So let's run Cypress. We're first of all running the application. Oops. And there we go. And let's run Cypress. This is the code that I've been showing earlier. And it's running the test. As you can see, we have 3 tests. It's doing the eyes open, eyes check window. Note that the tests have completed. Cypress is really, really fast in that way. But as you can see, the numbers are still running because it's doing the check windows in parallel to everything. We could have designed eyes Cypress to stop after every check window, but we really, really want those visual tests to be really, really fast. So not only are we paralleling the different widths, we're also paralleling the check windows themselves. And it's done. As you can see, it took 24 seconds to run 5 check windows. And if I would have added more, it would have been still that amount. We're talking roughly 30 seconds, 45 seconds. It depends on lots of things, but those are basically the numbers when you're running Cypress visual tests using Applitools Visual Grid. Great. Can we see that the test results? Let's go to the test manager, or what I call the dashboard, and there we go. this is the test. Let's not group by browser or by viewport. And we have all the tests, and we can see them running. Buy the cheese, book a doctor appointment, whatever. And those are the tests, and those are the screenshot. Obviously, the tests pass because I've already run this. Let's make it interesting. Let's make them fail. How do we make it fail? We'll go to components. This is the code of the test, and instead of doing a to-do, we will the to-do. We'll just change the color to green. Nobody really does that today. They use CSS, but we're just in a webinar right now, and let's run it again. A functional test would not have found this problem, obviously, because it just concerns visual aspects of the code, the CSS, the HTML markup, etc., etc. So we'll run it again, and it's doing those check windows. Let's see. And it's running them in parallel, uploading the DOM snapshots. When you ran the check windows, that check window took a million, like less than a second. That second is where it took the DOM snapshot of the page, took that snapshot, the whole images, etc., etc., and there we go. The test failed, and uploaded them to to Applitools, the visual grid. Now let's look at eyes, the dashboard, and we can see that the test has failed. Where? In the header. Now we need to approve or or reject the changes to tell Applitools whether this is a good change, thus a new baseline, or whether it's a bug. But it's a hassle because it's all in the header. It's a really big hassle, but Applitools has this really cool feature where it looks and says, oh wait, all these differences in all these screenshots, they're the same. So let's group them together, and I can just reject all of them at one time. And I've saved them as a failed test. Perfect. Let's fix the bug. There we go. But as long as we're here, let's do something else. We've just tested one width with one browser. Let's go to applitools.config.js. As you can see, we've tested it with Chrome in different widths. And let's change it to have 3 widths using Chrome and Firefox. And let's run it again. Remember, the tests are running locally. The DOM snapshots are being uploaded to Applitools Visual Grid in the cloud, and the screenshots are being taken in parallel in the cloud, in the Visual Grid. So let's see how long each check window takes. Same time. Even if we're testing 3 widths in 2 different browsers, the tests take roughly the same amount of time. Obviously, we'll probably get a little bit more time. Let's see how long it takes. And remember, it is already uploaded the DOM snapshots, ran the visual grid, found some browsers to work on, and it's taking the screenshots. And that's it, 26 seconds. The previous one was also roughly the same amount of time. Let's look at eyes. Let's refresh. We fixed the bug, and as you can see, there are lots more visual tests. I can group them by viewport. So I can see I have tests on 1024 or on 1280, or I can group them by browser. So I have Chrome and Firefox browsers. So yes, the same amount of time for multiple widths and multiple browsers. That is the power of parallelization and the power of the visual grid. As you can see, I'm terribly, terribly excited. Okay, so we've seen Cypress. We've seen how easy it is to write. If you know Cypress, just add eyes check window everywhere and you're done. If you don't know Cypress, it's about time to learn. It can be an experience, and it's a wonderful tool. What I wanted to show was not only Cypress, but Storybook. Storybook, and we'll see a Storybook right now, is a way to write libraries of components. If you have React components or Vue components or Angular components, then you can show them in a nice way. So the React to do MVC has these components: a header component, a footer component with 3 different states in it, to-do item, which has 2 states, completed and not completed, and a main section, which shows the to-do items in one big list. So this is a storybook. I created it by writing some code, running Storybook, and then Storybook gives me this really cool UI where I can preview all my components. What we said at Applitools was, hey, you've already got all your components in this really cool manner, and why not just test them almost as unit tests if you want, or integration tests? You don't even need to write code. We'll take your Storybook and visually compare all those tests. So let's run it. And remember, now there's no code. I don't need any code to do it, so I will just run iStorybook. And remember, 3 widgets we had, 2 browsers, and about 9 components, I think. So let's see, it's reading the stories and it's running the stories on iCypress, and it's doing it in parallel. Let's see. Too bad I didn't time it using time. And we're almost done. And are the gods of demo not with me today? There we go. And yep, those are all the components in my application. And there we go. We have a Storybook test written with no code, which tests all my component, very, very similar to UI testing. And that's about it for Storybook. So let's summarize. Fear is the mind killer. I always say that. Test to remove the fear of changing your code. Choose your methodology, diamond or pyramid. And don't forget, visual testing is a necessary ingredient of testing so that you won't fear changing your HTML and CSS. And visual testing cross-browser and cross-responsive widths is crucial. You can't just test one. Visual testing, so that means that visual testing needs to be parallelized, and try to parallelize the screenshots, not the test. And if you want to do that using a commercial tool, Applitools Visual Grid is a great tool for that. Currently, we support Cypress and Storybook, but in the coming months, we will be adding more browser automation tools that we will integrate with. Thank you very much.
Questions? Gil?
Oh, sorry. Questions, anybody? Thank you, Wendy.
Questions? Question mark? Are you
question? Yes, I am ready. As I said, I'm really excited. So excuse my.
No, you're always excused. So I just first of all, I saw a lot of people asking for demos on visual testing with Applitools, personalized demos. So obviously, this is not the place and time, and Gil won't go into it, but definitely ping me in the questions panel if you're interested, and I'll make sure that one of our solution architects gets back to you. So again, apologies, we can't get into like a proper Applitools Eyes demo right now. This time is reserved for questions. So ping me and we'll take care of it post session. Thank you. And now for the questions, Gil. First one, it says here that it relates to page 56 of your presentation, and the question goes: should we test for 768 width or below pixels on the desktops, or just target related width? Parenthesis 768 pixels and below pixels for the tablets and mobiles layout. Want to hear your thoughts and get your feedback.
Right, and my response is it all depends on what the developers did. Developers, when they're writing the CSS and HTML markup, they have this notion of I'm assuming lots of developers here understand it, have notions of breakpoints. So they have different CSS in a way, or conditionally do the CSS so that it will be different in like 400 and 768 and 1024 and whatever. And each developer chooses their breakpoints a little bit differently. I would say test each one of those breakpoints for whenever you test for the different widths. Talk with the developer, or if you are the developer, then you know those widths and target those widths to verify that your application works for all the breakpoints. Yep. Next question.
Yeah, sorry, I was on mute. So we're getting a few questions about mobile devices. Generally, can this also be applied to mobile apps, either hybrid or native? And can this be done with iOS devices?
Right. Currently, we don't target iOS devices, but we have the second best thing. We run Chrome. Chrome has this device emulation mode where it emulates the width and the pixel ratio and the pixel density and all those mobile things like landscape and portrait. So you have the next best thing. You can check it with the correct pixel density, the correct landscape mobile, etc., not on the main device, but next best thing. Once we have, well, and if you think about it, if you're running Chrome, you're basically running the same browser that all Android devices have. Once we have Safari support, then we will also be targeting iOS like by extension. So the answer today is we use Chrome emulation mode, which is great everywhere, and it will probably find most of your visual bugs. It will find Chrome Android visual bugs. For Safari, for those edge cases, we'll have to wait until we have full Safari support.
People here are asking for timelines, but I won't put you on the spot like that.
Yeah, 2 weeks. Oh, just joking. No, I wish.
So they're also asking about when are we adding Edge and IE11?
I'm not sure I'm allowed to say that, but definitely definitely is a big word in the half-year time frame. Yeah.
Okay, next one. So next question: to create the first baseline, do you simply run the test, view the fails, and then accept them as the new baselines?
Could you repeat that? I'm sorry.
Yeah, sure. To create, it's about creating the first baseline. It's about initiating. To create the first baseline, do you simply run the test, view the fails, and then accept them as the new baselines?
It's actually simpler. The first time the test runs, it passes. And it creates the baselines automatically. Theoretically, you should go to the Applitools test manager, that dashboard that we saw, and go through all the screenshots the first time, the first test, to ensure that they are the correct baselines. But we decided on the default of first test passing to make things easier.
Next question. JavaScript often changes the DOM elements. Is that a problem?
No, not at all. That is the power of DOM snapshots. So let's say you click, and that click changes the DOM elements. The JavaScript code that runs in the click event handlers changes the DOM elements. And then you do check window. Okay, eyes check window, as we saw. Not a problem. It will take a DOM snapshot of the DOM as it is at the time of the check window, which means after the JavaScript has run and mutated the DOM. So we're taking the DOM snapshot exactly at the time of the eyes check window. You will get the exact DOM at that same time, which means you will get the exact same screenshot as you can see on the browser page. So yes, not a problem at all.
Can we ignore some parts of the baseline when comparing, for example, login names, menu, etc.?
Yeah, date time is a good example. Definitely, we have lots of support for that. Both in the code, in the eyes check window, you can ignore it. You can say this selector, please ignore, this selector, please ignore, this box, and you can give absolute coordinates, please ignore. Or in the dashboard, you can use a nice drag and drop way where you can mark which parts of the page to ignore. It's a lot of times it's much easier. You can even have floating regions. Lots of options there. I won't go into the details, but definitely we have support for that.
Would browser updates, for example, new version of Chrome, would cause a previous screenshot to be out of date?
Yes, if you're not using Applitools. You will get a lot of false positives there. We've seen that. We even have a really cool blog post about it on different versions of Chrome creating false positives for people that test using pixel by pixel tests. And I think the move from 68 to 69 and 69 to 70 generated a lot of those. But as I said, Applitools has visual algorithms that are very complex and ignore exactly those details. They don't care. Whatever the human eye sees, that's what those algorithms sees. We've moved and we have no problems. And we've seen that happening in the move from 68 to 69, 69 to 70 in Chrome, where we didn't have any problem and no false positives and no false negatives at all. So yes, if you're using a pixel by pixel algorithm tool, not if you're using Applitools. You should have no problem.
Would I be able to compare InVision screen prints with the actual application? By the way, this question, we got another question with regards to PDFs and image files such as PNGs and JPEG.
And the answer is yes. While our algorithms are geared towards screenshots, which has a particular case, we have lots of customers that use them for images, PDFs, and all kinds of sketches and screenshots. Definitely try it out. We have an image SDK where you can just give an image, or a PDF SDK where you can just give the PDF, and we do all the heavy lifting behind it to generate the screenshot. So yes, the answer is yes, not a problem.
How do you handle iframes, since some part of the page can be displayed much later inside of the iframe, for example, graphs, while the basic structure is already loaded?
Stabilization is a big thing. Definitely. First of all, Cypress handles it for us. In the case of Storybook, it's not a problem because there are no iframes. In the case of Cypress handles it for us. It waits for everything to like stabilize, and it has all kinds of algorithms for doing that. In our visual grid, we also have stabilization algorithms that wait for the page to load, including obviously the iframes. And because we're using internals of Chrome and Firefox like Marionette and CDP and all kinds of technical stuff, our capabilities of waiting for stabilization are much higher than a regular, let's say, Selenium WebDriver test. And we can be much more generic. Yes. So to the answer, we shouldn't have any problems with iframe loading more slowly.
How do you handle animations?
Great questions. I love them, especially given that I have an answer. We just stop them. In Firefox, we stop them using CSS, and in Chrome, we stop them using internal DevTools protocol stuff. So we stop them at a certain time. So you basically, when taking the screenshots, there are no animations; they're disabled.
Great. What is the best time to automate visual tests, when the final design is done or before?
Well, my belief is that visual testing is not different than any test. So whenever you have code that is running, especially front-end code, because visual testing tests front-end code, do the automated visual testing. As you can see, it's really easy. It's like 10, 20 lines of code, click, 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 check window, click, 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 check window. You'll get a huge amount of confidence from those visual tests. And as you can see, they run in 30 seconds, 45 seconds, not a big time waster for us. So my answer is, once you write the code, write the tests. That's the best way for all the tests, not only visual tests.
How about the React Native PWA, and can Storybook be used for visual testing?
Okay, so PWA, not a problem. A PWA, a progressive web app, is a web app. So just test it as you would any web app whatsoever. React Native is a different thing. React Native is not a web app, unfortunately. So currently it can't be tested using the Visual Grid. You can test it using Appium SDK. We have an Appium SDK. So that should work with React Native applications or any mobile applications whatsoever. Storybook? Yep. Storybook for React Native we don't support. We support only web Storybook. So that's the answer.
Awesome. So I'm just looking for the next one. They're just coming in so fast, so I lost my train of thought. And just one more thing, because I'm seeing these questions come up again. So yes, we are recording the session and it will be sent to you via email by Monday. So don't worry about that. Let's take one last question because we are out of time. So with regards to the algorithms working on the image diffs, is this machine learning based, or is it just an algorithm?
Unfortunately, there's no one answer to that. We have, I don't know, tons of algorithms. I don't know exactly the number. All of them working on the image at the same time. Some of them are image processing algorithms. Some of them are machine learning algorithms. And they all look at the page in various ways to ensure that there are no false positives or false negatives. But yes, we do use machine learning too.
Awesome. So unfortunately, that's all the time that we have for today. I want to remind again that if you do want a personalized demo of Applitools Eyes and visual testing, then just ping me in the questions panel. I'll make sure someone from our team gets back to you. And of course, the recording will be sent to you by Monday. I want to thank everyone that joined us today for this live session. And of course, I want to thank our speaker, Gil Tayar, for this, first of all, incredible presentation and for the incredible work that he has done on creating all of the stuff that you saw today. So thank you.